Hello and welcome to lesson 713 for 5th grade math. I'm on page 272. Today we are predicting Old Faithful's eruptions. Before I get too deep into things, I just want to forewarn everyone. My cat is currently on top of my bookshelf, and when she comes down off the top of that bookshelf, it tends to make a crashing noise. So don't be alarmed if that happens midway through this lesson, as I feel like it will. Now, Old Faithful. It's a geyser located in Yellowstone National Park. That's the first national park in the history of the United States, and it also happens to rest on top of a super volcano. It's actually, the park itself is almost entirely composed of, it's basically inside of a caldera, which is the inside of a volcano. The volcano is dormant. That means it doesn't really erupt. So to us, when you go there, it really just looks like regular land. There's trees, there's water, there's all those things. But beneath the surface is where you still have a lot of like low-key volcanic activity. And what happens in the case of geysers, when that water slips down beneath the surface and comes in contact with that volcanic activity, with magma or the heat from magma, the water boils, pressure builds, and you get water spewing out into the sky. And so Old Faithful is one of the most popular examples of a geyser that we know in the United States and in the world. And the reason we know Old Faithful so well is because it's reliable. We can tell when this geyser will erupt. So let's take a look here. It tells us it's not, I'm going to paraphrase this. They say Old Faithful is not the tallest geyser, but it is pretty much the most dependable, which means it erupts at predictable intervals. With a lot of geysers, you don't entirely know when it's going to erupt. Maybe when you're around it, it will erupt while you're there and shoot water into the sky, or maybe it won't. But with Old Faithful, you can actually, if you go to Yellowstone National Park, there's a schedule, and you can basically time it out. Like, hey, I want to go to Old Faithful around that time, because that's when it's going to erupt. And they're going to give us the formula that shows them how to figure out when Old Faithful will erupt. Now, it tells us here that the wait time, this means how long you will have to wait for Old Faithful to erupt, is equal to the following. It is 10 times the length of the last eruption in minutes, plus 30 minutes on top of that. So if that's confusing to you, why don't we head down to the actual table here and see if we can walk ourselves through exactly what they're talking about. So you'll notice this table is broken into an X and a Y. We've been doing a lot of graphing lately, and you're going to be doing a little bit more graphing here today. And here's our X-axis, of course, and here's our Y-axis. Now the X-axis in this case represents the length of the previous eruption. Previous meaning last in this case. So you notice the very first X variable or coordinate is 1. So this is saying the last eruption, the last time the water shot into the sky, it did so for 1 minute. Okay, so here's how we find out how long it's going to take for the next eruption. We're going to take that 1 minute, which is the length of the last eruption, multiply it by 10. So what's 1 times 10? It's 10. And then add 30 minutes to that. So we're going to take 10 minutes and add 30 minutes. And what do you get? That's how they got their 40. Okay, so let's take a look at number 2, where we don't actually have the eruption time actually filled in just yet. After this 1 minute eruption, they tell us that the next eruption now lasted for 2 minutes. So the first one, pretty short. Next one, twice as long. Let's go ahead and plug this 2 into our formula. So wait time equals 10 times the length of the previous eruption. So in this case, it's going to be, I love using a separate piece of paper for this stuff, 10 times the previous eruption length, which is now 2 minutes, plus 30. If you notice, I put the 10 times 2 in parentheses, so that reminds me to do this equation first. Do the 10 times 2 first. And what is 10 times 2, by the way? Yeah, it's 20. So in this case, it's going to basically be 20 plus 30. I'm going to rewrite it a different way. And what is 20 plus 30? 50. So your wait time for the next eruption will now be 50 minutes. And do you notice that the wait time's not always the same after every eruption? In fact, it's changing all the time, but they have this formula that they found out works out pretty well, pretty reliably. So even though the wait time is changing, they can kind of figure out how much is it changing each time. So let's keep going. Let's keep this ball rolling. Now the eruption is lasting for 3 minutes. People are getting luckier. You can watch it erupt for even longer now. So back to the same formula, 10 times, and I know this, just a quick reminder, that asterisk is like a multiplication symbol. Okay, so 10 times 3 plus 30. And if it's easier for you, if this confused you, and you can just do 10 times 3 in your head, which I know is 30. And if you can do a little mental math, that's fine too. 30 plus 30 equals, I know 3 plus 3 is 6. Add a 0. 60. So now our wait time is 60 minutes. Okay, I'm going to maybe offload these next ones onto you guys to do on your own. And I'm going to skip down to this one. I'm going to skip down to 2.5. Okay, so in this case, we are going to follow the same equation, which will be 10 times, oh, there went something. Oh, it's the cat. She came down and everything's fine. Phew. So 10 times 2.5, also known as 2.5, plus 30. I'm going to show you guys a quick reminder of how we can do a mixed number times a whole number. And I'm going to use, I'm going to split this up. I'm going to do a 10 times 2, and I'm going to do a 10 times 1/2. I may have to let my cat out in a moment. She's had enough of this. So we know 10 times 2 is 20. And 10 times 1/2 is basically saying what's half of 10. So take 10 and split it in half, and I know we get 5. So 10 times 2.5 altogether would equal 25. So now we're going to take that 25, which is basically this, what we just figured out, plus 30. And if you can't do this one mentally, you can go ahead and just solve it vertically if that helps, or with a calculator. I think calculators are okay for this page. 25 plus 30. 0 plus 5 is 5. 3 plus 2 is also 5. So we got ourselves a wait time of 55 minutes here. Okay, I think I'm going to pop in for this last one too. Hopefully you're not too bored yet. I don't know why I'm saying that, you probably are. Regardless, this last one I think is going to be a little bit tricky, because if you take a closer look, you'll notice that instead of giving us the length of previous eruptions, they're giving us the minute-long wait. So we're going to have to kind of work our way backward. Okay, so this means we've already added 30 minutes. This is the result of the equation up top. This might get a little confusing. So they must have done 10 times something plus 30 equals 35. So what we're going to do is reverse the whole situation here. We're going to take 35 minutes and subtract 30 to work our way backwards. So what's 35 minus 30? And that will be 5. So now that means 10 times something equaled 5. So if you look back at what we just did for the last problem, they kind of gave us a fun little hint. We already did a problem where 10 times something equaled 5. And what was that something? It was 1/2. We know 10 times 1/2 equals 5. So in this case, if we continue reversing, we took away 30, we got down to 5, which means 10 times something had to equal 5. And we know 10 times 1/2 equals 5. That must mean this is our x. This is our length of the previous eruption. 1/2. And let me just say, if that confuses you to no end, it's okay, because that was confusing to explain. This was really tricky. But to walk you through as to why this works, we can test it. Let's put half in as our length of last eruption. So 10 times 1/2 is just like saying what's half of 10. And we already figured out in the last problem, half of 10 is 5. So we have 5 plus 30 equals 35. So 1/2 checks out. Okay, so it's going to be your job from here to write each pair of values from the table as an ordered pair. And we know an ordered pair always has parentheses separated by a comma. They're really driving this point home to you guys. And then you'll have some questions to answer about Old Faithful after you are sure to plot each point on the grid to the right here. Only thing I'll point out for you to remember, this is our x-axis, and x-axis is always the horizontal plane, we call it. It's the one that is flat. And then the wait time will be your y-axis, which is your vertical axis here. Okay, that's the long and short of Old Faithful. If you're bored, I recommend researching Old Faithful, researching Yellowstone National Park. There's so many cool things there. I had a chance to see Old Faithful a few years ago, and it was cool, but I don't know if it was my favorite part even, because there's so much other wonderful things to see at Yellowstone. For instance, our car almost got hit by a buffalo. So if you're interested when you're done, check it out, do some research on Yellowstone National Park, the super volcano that's sitting dormant in the United States of America. And until next time, leave a comment if you have any questions. I'll see you guys soon.